Hi, good and welcome to this discussion on physics. Today, we shall be looking at problem on quantum mechanics. The problem says, or the question says, a thermal neutron has speed v that corresponds to the room temperature T equals 300 Kelvin. What is the wavelength of the thermal neutron? So this question is an application of the Broglie's hypothesis. And what did the Broglie propose? He proposed that the momentum is related to the wave vector by this P equals tau k, where this is h upon 2 pi and k is the propagation constant. This is 2 pi upon lambda. This is the wavelength. So this cancels. We have h upon lambda, so that P equals h upon lambda. So we now see that a material particle moving with momentum p has a wavelength given as, if you make lambda subject of the formula, we have that this is lambda equals h upon p, where h is Planck's constant. This is the momentum, and this is what? Wavelength. So we want to find the the wavelength of the thermal neutron. So the wavelength of the what? Thermal neutron. The wavelength of the thermal neutron. So this will be the momentum of the thermal neutron, and this will be the what? The Planck's constant. At temperature T, average energy given as this is represented as 3 upon 2 kT, where K is the Boltzmann's constant. This is the what? Boltzmann's constant. T is the temperature. This is what? Temperature. So this value of Boltzmann's constant is given us, so K is given as 1.38 times 10 raised to the power minus 23 joule per Kelvin. So this is the value of this Boltzmann's constant. It's constant. So recall that kinetic energy is given as half mv squared, which we can reconstruct as, you can see that this is m squared v squared upon 2m. So once this cancels, we have something like this. Okay? So, and momentum is defined as the product of mass and velocity. So we can have something like this, that this is p squared upon what? 2m. This is the what? Kinetic energy. So we can now equate this kinetic energy to the energy at what? Temperature T. So if we do that, we have that this is p squared upon 2m equals 3 upon 2 kT. So in this case now, this will be the mass of the neutron, and this is the momentum of the neutron. This is Boltzmann's constant, and this is what? Temperature. So if we make P subject of the formula, we have that from this, from star, we have that cross multiply, have that 2p n squared equals this, we multiply this, we have 3 kT times 2mn. this can cancel this. I have that the momentum of the neutron is 3 kT half mn. So this is now represented as, to make this standalone, we square root both sides. So we have this 3 kT m what n. So we have now found the momentum of the what? The neutron. The expression for momentum, expression that will help us get the momentum of the what? Neutron. But the question is asking to find the wavelength of the thermal neutron. So the wavelength of the thermal neutron now will be from this formula H upon P, the Broglie's relation, where this is given as 6.63 times 10 to the power minus 34 jouleseconds. So we can now have that wavelength for the thermal neutron will be, so we have 6.63 times 10 to the power minus 34, this is jouleseconds, upon square root of, this is 3 times, this is Boltzmann's constant. This is what? Boltzmann's constant. It is given as 1.38 times 10 to the power minus 23 joule per second, joule per Kelvin, sorry, and the temperature is 300 Kelvin, and the mass of neutron is a constant, is given as 1.67 times 10 to the power minus 27 kilogram. So once we evaluate this, we now have that the wavelength of the thermal neutron, will be, this will be lambda equals 1.4 Armstrong, and 1 Armstrong unit is the same thing as 10 to the power minus 10 watts meter. So we can have this as lambda equals 1.4 times 10 to the power minus 10 meter. So this is the wavelength of the thermal neutron. So the question can come like this: what is the wavelength of the thermal neutron? And you'll be given these options. You'll be given these options as, let's say, given options as A as 1.4 times 10 to the power minus 10 meter, B 2.6 times 10 to the power minus 3 meter, then let's say C as 6.7 times 10 to the power minus 12 meter, and D equals let's say 3.2 times 10 to the power minus 5 meter. You now see that the answer now is this. So the wavelength of the thermal neutron is 1.4 times 10 to the power minus 10 meter. So we shall be solving other problems, other questions on quantum mechanics. So you do well to check back in this channel. So we upload videos on mathematics and sciences. If actually you have enjoyed this video, you can subscribe for more updates like this. You can go back to the playlist and check the videos that suits your interest. Thank you so much.